Good evening, all. So in this session, I want to discuss about analysis of wave frame by using slope detection method of analysis. Myself, Rajshekhar, assistant professor in the Department of Civil Engineering, Pittsburgh. So these are the two lecture outcomes. After completion of this lecture, student will be able to calculate the fixed moments for different loading, and can able to analyze this wave frame by slope detection method. First of all, we'll understand what is sway. Sway is nothing but horizontal movement of one end of the column. Sway is nothing but horizontal movement of end of the column is called sway. Horizontal movement of end of column. One end of the column is called sway. So this is the, let us say this is the frame. If it is subjected to loading or any other external effect, is subjected to, it will sway like this. After deformation, this is the sway position. So the before sway, this is the position of frame. After sway, this is the position, initial position. Let us say this is A and this will be A dash. Then this will be, sway will be denoted by capital delta. So this is also capital delta. Why it is capital delta? Both are the same. Why? Because they are, both the columns are connected together. Both the columns are connected together, and so we are using in slope detection method of analysis. Axial deformations of the members are we are neglected. So from this condition, axial deformations of the member are neglected. So we can consider A dash and B dash will be equal to B dash will be equal to delta. That is, so equal amount of sway will take place for the both the columns. Equal amount of sway will take place for the columns. So sway is nothing but horizontal movement of one end of the column. Horizontal movement of one end of the column with respect to the other end, that is called sway. Horizontal movement generally denoted as sway. So we'll identify whether the given frames, sway frames or not. First we'll identify. So before going to that, the sway is possible in three ways. Sway is possible in three ways. So first one is due to supports, because of supports. Second one due to the moment of inertia I, and third one is related to the loading. Third one. So causes of sway is three types. First one is due to supports. So if the supports are different supports and different level, supports are in different types of supports. Like if it is a hinged support or roller support, fixed support. One end is fixed, another end is roller, then it is called a sway frame. One end is fixed, another end is roller, then the sway frame may possible sway. So frame lo sway వచ్చే ఛాన్స్ ఉంటుంది. ఒక ఎండ్ ఫిక్స్డ్ ఉండి ఇంకో ఎండ్ హింజ్ ఉంది అనుకోండి, there will be chance of that frame may be sway frame. Okay, and first one is different supports. For a frame, two different supports. First we have two supports, one fixed support, another roller support, or one fixed support, another hinged support. Okay, so second one is supports are at different level. Supports are at a different level. Either the support is different support or different level, the frame is considered to be sway frame. And second one is moment of inertia of the column. So if you see, this is a frame. In this, these are the two column members. This is B member. So moment of inertia of column member, one column member is different from other. Then the moment of inertia say both the column members moment of inertia say they are same, then that is called a non-sway frame. If it is different, then that is, if it is a moment of inertia different, then it is called a sway frame. And third one is loading. If the loading is symmetrical about vertical axis, then it is called a sway frame. Otherwise, it is called a non-sway frame. The loading is symmetrical about vertical axis. If it is symmetrical about, the loading is symmetrical about vertical axis, then it is called non-sway frame. Otherwise, it will be sway frame. Okay. So let us see. First given figure. Supports are at different level. So we can directly say that this is a sway frame. Coming to the second figure, so moment of inertia of columns are different. This is the moment of inertia of column 1 is I, moment of inertia of column 2 is I2. So this is a sway frame. You can directly say. And if you see third figure, the loading is not symmetrical about vertical axis. So this is eccentric loading is there. So this will cause this sway. So this is also a sway frame. And fourth one is related to different support levels. This is also moment of inertia same but different level. And next one, figure E. Coming to figure E, supports are this same supports and same level, but moment of inertia of column 1 and column 2 is different. So this will cause this way. Moment of inertia, both the columns are different. So this will chance sway. And the loading is not is also symmetrical about y axis. So this loading may not cause this way, but the moment of inertia will cause this way. So sway is possible in three ways. If the supports are at different level, then sway is possible. Different supports in the sway possible a chance. Second one is moment of inertia both the columns. If it is different, then sway is possible. Third one is the loading is not symmetrical about vertical axis, then the sway is possible. So these are the possibilities of sway in the frames, especially. Okay. So now the question is how to convert the sway frame into non-sway frame. How to convert the sway frame into non-sway frame. So sway frame can be converted into non-sway frame by providing proper supports, horizontal supports. If we provide the support like this, whatever the load we are applying here, that will carry to the support. So that means sway is not possible for this particular frame. So similarly for all other support frames also, we can provide proper support to avoid the sway. Okay. Yeah, right. Students, will see one problem related to the sway. The given problem is given that analyze the frame as shown in figure by slope deflection method. Is not mentioned that whether the given frame is sway frame or not, non-sway frame is not mentioned properly. So we need to identify from this given figure, we have to identify whether the frame sway is possible, the given frame sway is possible or not, that we need to identify first. So from our fundamentals, supports are a different level. Supports are a different level and the moment of inertia of column 1 and different from column 2. So sway is possible. Directly we can say that this is a sway frame. Okay. So sway is possible like this. So this is the elastic curve of the frame. So this is the deformation. So this is the delta sway. Before sway, this is the position. After sway, this is the position. So deformation is delta. Horizontal translation in this delta. This is delta. So for this, unknown displacements, if you identify displacements for the given frame, unknown displacement for the given frame, theta b is unknown and theta c is unknown, as well as delta is also unknown. If it is a non-sway frame, if you observe, if it is a non-sway frame, let us say supports are same level and moment of inertia is also same, then the unknowns are only theta b and theta c. Theta b and theta c. For sway frame, additional one unknown will be there, that is delta is there. Additional one unknown is there, that is delta is there. So we have to be careful about this delta. Okay. So right, I will see the step-by-step procedure. In the first step of analysis, we are going to calculate the fixed moments. First step of analysis, we are going to calculate the fixed moments. If you observe the AB span as well as CD span, there is no load. Only for the BC span is subjected to uniform distributed load. Okay. So fixed moment, as we know, the fixed moments will develop due to applied load only. Fixed moments develop due to applied load. Okay. So right, that means for AB span and DC span, there is no load. That means MFAB, MFBA, MFCD, MFDC will be equal to 0. Coming to BC span, so BC span is subjected to uniform distributed load. As we know, if beam is subjected to uniform distributed load, fixed moment can be calculated by using the formula WL square by 12. So it is acting anti-clockwise direction, that is a negative. So for this, resting moment will be positive because here is acting clockwise direction. So this is minus WL square by 12 and this will be the plus WL square by 12. So this is the M, let us say this is B and this is C. MFBC, this is called MFBC. MFBC will be equal to minus WL square by 12 and MFCB is equal to plus WL square by 12. If you calculate it, you will going to get 120 kilonewton. So now coming to the second step. The second step of slope deflection method of analysis, formation of slope deflection equations. Formation of slope deflection equations. Formation of slope deflection equations. So right, if you observe the given figure, so this is a fixed support. For fixed support, theta A is equal to 0. At A, fixed support, theta A is 0. At D, fixed support, theta D is also 0. At B, theta B is unknown, that we need to calculate, and at C, theta C is unknown, that we need to calculate, and along with this theta B and theta C, delta sway is also there. So we have three displacements unknowns, are three basic unknowns are displacements are theta B and theta C and delta. These are the three unknowns. So now we have to substitute, we need to develop the slope deflection equation for all the three spans. So we have three spans, that means we can able to develop 6 slope deflection equations. Slope deflection equations, we can develop 6 slope deflection equations. They are MAB, MBA, MBC, MCB, MCD and MDC. So we know that very well about the slope deflection equation. I am just writing for the MAB. MAB is equal to MFAB plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. So this is the slope deflection equation. So here you need to substitute for AB span, you have to substitute theta A is equal to 0 and theta B is unknown. Delta is also, if you see, delta is delta only here. Why? Because sway is possible. So in place of delta, you need to substitute delta as it is, you need to write like this. Okay, right. So, right, 2EI by L. So MFAB is 0. Why? Because AB span is not, for AB span there is no load. So MFAB is equal to 0. MFAB is equal to directly you substitute 0. And to L value is 4. Substitute it. 2EI by L is 4. 2 theta A plus theta B minus 3 delta by L. So right here theta A is also 0. Why? Because fixed support. A is a fixed support. Theta A is 0. So theta B minus 3 delta by L. That means so 0.5 EI theta B, 0.5 EI theta B minus 0.375 delta. 0.375 delta. You consider this as equation number 1. So similarly, you write the equation for MBA. So we know MBA will be equal to MFBA. This is MFBA plus 2A by L to theta A plus 2 theta B minus 3 delta by L. So if you substitute theta A is equal to 0, theta A is equal to 0, and then you will going to get this equation EI theta B minus 0.375, 0.375, 0.375 delta. You can write this is equation number 2. This is equation number 2. Similarly, you write for MBC. So MBC for MFBC is there, fixed moment is there, that is minus 120. MFBC just now we are calculated. MFBC is equal to minus 120. You substitute 2 EI. So in place of I, you substitute 2I. Why? Because the moment of inertia for the BC member is 2I. 2 theta B plus 2 theta C. 2 theta B plus theta C minus 3 delta by L. 3 delta by L. For BC member is not sinking. So this is a beam member. For B member, there is no relative displacement of the both the supports. Support B and support C are the same level. That means delta will be equal to 0. That's vertical displacement is 0. Delta V equal to 0. So we need to substitute in place of delta for the BC member. For the B member, we need to substitute as it is 0. Okay. Then solve it. You will going to get another equation. This is equation number 3. Let us see. So similarly for MCB also, you write the same. That is equation number 4. So coming to CD member. So CD member, there is some horizontal displacement is there that you have to write. MFCD plus 2 EI by L theta B plus 2 theta C minus 3 delta. 2 theta C plus theta D minus 3 delta by L. L is equal to 6. CD span is 6 meters. So you can solve this equation, you will going to get, substitute theta d is equal to 0. Theta d is equal to 0, I is equal to I. Okay, if you solve it, you will going to get another equation. This is equation number 5. So similarly, you solve this, you will going to get another equation. This is equation number 6. So we got from the 3 spans, we got the 6 equation, that is slope reflection equations we have developed. So how many unknowns we have? 3 unknowns we have. So we cannot. So right. So 3 unknowns is there. So we have 6 equations. Okay. But all the equations are in terms of theta b, theta c, and delta only. Theta b, theta c, and delta only. Okay. Now, so after calculation, after formation of slope reflection equations, we need to write this equilibrium equations. We have to write the equilibrium equations. As we know, so this is the frame. So this is a frame equilibrium for the frame. Joint equilibrium equations will be summation of moment at B equal to 0 and the summation of moments at the joint C will be equal to 0. So we have 3 unknowns actually. So unknown displacements are 3, that is theta B, theta C, and delta. So we cannot analyze, that means we cannot calculate theta B, theta C, and delta from this joint equilibrium equations. Along with the joint equilibrium equation, another equation is also required for complete analysis of this, for calculating of theta B and theta C and delta value. So for that, so right, there is a horizontal sway is there. Because of the horizontal reaction it supports. So horizontal reaction HA and HD will going to develop at the supports. HA, HD will going to develop the supports. So because of this, I want to write another equation. Summation of forces in horizontal direction will be equal to 0. So these are from these 3 conditions. So 3 equilibrium equations and 3 unknowns we can able to solve easily. So by using this concept, summation of moments at joint B equal to 0, summation of joint C equal to 0, summation of horizontal forces at x direction will be equal to 0. If you add it, you will going to get theta B, theta C, and delta from these conditions. So right, first you will see summation of moment at C equal to 0, summation of moment at B equal to 0. If you write summation of moments at B equal to 0, that means at B, what are the moments we have? At B, joint B, BC member is meeting as well as BA member is meeting. So that means moment MBC plus MBA, moment in BA member plus moment in BC member will be equal to 0. That is the meaning of MBC. Summation is nothing but whatever the moment is available at B, if you add that moment and equate to 0, that means MBA plus MBC will be equal to 0. So this is the equation. So already in the step 2 we are calculated MBA and MBC. You add both and equate to 0. You add both and equate to 0. You are going to develop another equation. Let us say equation number 7. Let us say. Okay. Now we use another equation, that is summation of moment at C equal to 0. Summation of moment at C equal to 0. That means at joint C we have 2 members are meeting. That is BC member as well as CD member. BC member, CB member as well as CD member. That means MCB plus MCD equal to 0. MCB plus MCD equal to 0. So we are already calculated MCB and MCD. MCB, MCD. Add it. You 4 and 5. So you add 4 and 5 and equate it to 0. You are going to get another equation. This is equation number 8. Let us say. Okay. So if you observe this, this is a equation in terms of theta B, theta C, delta. Okay, 3 equations, 3 unknowns is there, 2 equations is there. So that means we have to write another equation, that is sigma fx equal to 0. So sigma fx equal to 0 is 0. HA plus HD will be equal to 0. HA plus HD equal to 0. So HA is unknown, HD unknown. HA is unknown, HD is also unknown. How to calculate HA and HD? For the calculation of HA and HD, for the calculation of HA and HD, for the calculation of HA and HD, we need to draw the free body diagram. We have to draw the free body diagram of the given figure. So if you write the free body diagram, at A, at support a clockwise movement will going to develop. Clockwise movement will going to, that is MAB, MAB. At B, a clockwise movement will going to develop, that is MBA, MBA. At A horizontal reaction will be there, at what vertical reaction will be there. Okay, so this is the free body diagram. So now I want to, from this free body diagram, I want to calculate HA. So we know B is a joint B, at B, moment is 0. Summation of moment at B equal to 0. You take summation of moment at joint will be equal to 0. Then if you write like this, to consider clockwise moments are positive, that is MAB. So moment at, if you write moment at B equal to 0, yes, moment at B equal to 0 for this column member only, for the only one column member. I'm drawing the free body diagram of this column, free body diagram of this column. This is the free body diagram of this column. Okay, I'm writing here. So I'm considering clockwise moments are positive. MAB is producing clockwise effect. MBA is also producing clockwise effects. So MAB plus MBA. So HA value producing anti-clockwise. HA is producing anti-clockwise effect. So that is minus HA into, which is length and let us say LAB. Length is LAB equal to 0. That means HA will be equal to MAB plus LBA by MAB plus MBA by L. MAB plus MBA by length of the number. HA will be equal to, we can write like this, HA will be equal to, for the calculation of HA, what we did, we have just taken moment about joint B and equal to 0 for the first column. That's it. We have drawn the free body diagram. Just drawn the free body diagram and we are calculated MAB plus MBA by L. HA will be equal to MAB plus MBA by L. So similarly, for the calculation of HD, you take the moment about C, you draw the free body diagram of this column, draw the free body diagram of for the second column, and take moment about C and equal to 0. You're going to get HD will be equal to MCD plus MDC by L. So that is a formula. Otherwise, you can remember. You remember MAB plus MBA by L. Okay. So now after calculation of this one, you have to substitute sigma fx equal to 0. This is another equilibrium equation just now I discussed here. So summation of moment at B equal to 0, summation of moment at C equal to 0, and sigma fx equal to 0. HA plus HD is equal to 0. Okay, this is another. So 3 unknowns, 3 equations. Okay. So HA is nothing but MAB plus MBA by L. HD is equal to MCD plus MDC by L. Now you substitute MAB, MBA, MCD, MDC. So that we are calculated in step 2. Step 2. You substitute it. Finally, you are going to develop another equation. Let us say this is equation. And solve these equations. Let us say this is equation number 9. Solve 8, 7, 8, 9. Solve 7, 8, 9. You will going to get EI delta, EI theta C, EI theta B. EI delta, EI theta C, EI theta B. What you need to do, you just substitute EI delta, EI theta C and EI theta B, EI delta, EI theta B, EI theta C in step 2. In step 2, MAB, MBA, MBC. In step 2, theta B, theta C, whatever is there. So you substitute it. You will going to get the final end moments. You will going to get the final. So this is the summary of the problem. Summary of a sway problem. So this is the one lecture level practice problem. Analyze the frame as shown figure by slope prediction method. First we have to identify this frame. This is sway frame because the loading is not symmetrical about vertical axis. Though both the supports are the same and they are in the same level, the loading is Moment of inertia is also same for the both the columns, but the only difference is the horizontal load is not symmetrical about vertical axis. So that is the reason sway is part. So same procedure we need to add for the analysis of this sway frame. So thank you one and all.